Hi everyone, this is Sir Elmer, and once again, welcome to my mathematics video, and today we will be talking about the sum and difference of two cubes. So in the sum and difference of two cubes, we will be having two types of factoring. One for the sum of two cubes, and the other one is for the difference of two cubes. So for the syntax of the sum of two cubes, we have the first equation. X cubed plus y cubed equals the quantity of x plus y times the quantity of x squared minus xy plus y squared. Now, for the factoring of the difference of two cubes, we have x cubed minus y cubed equals the quantity of x minus y times the quantity of x squared plus xy plus y squared. So, if we analyze, the factoring of the sum and difference of two cubes entails two factors wherein the first factor is a binomial factor and the second factor is a trinomial factor. So how do we factor the sum and difference of two cubes? We will find out. But before that, we must first understand what are perfect cubes. So I have here the first column, the perfect cube numbers, and I have listed the first 5 perfect cube numbers in mathematics: 1, 8, 27, 64, and 125. So why were they called perfect cube numbers? So they are called perfect cube numbers simply because they are the result of multiplication of a number 3 times to itself, such as 1 times 1 times 1 for number 1, 2 times 2 times 2 for 8, 3 times 3 for 27, 4 times 4 times 4 for 64, and 125 we have 5 times 5 times 5. So that is why they are called perfect cube numbers, simply because of that reason. Now for the variables, just like with their numbers counterpart, so these examples that I have listed here, a cube, b raised to 6, c raised to 9, d raised to 12, and e raised to 15 are perfect cube because they are also the result of the multiplication of a variable 3 times to itself, such as a times a, b squared times b squared times b squared for b raised to 6, c cubed times c cubed times c cubed for c raised to 9, d raised to 4 times d raised to 4 times d raised to 4 for d raised to 12, and e raised to 15, we have e raised to 5 times e raised to 5 times e raised to 5. Now, one thing more, if we analyze their exponent, these variables have this as their exponent. So what can you observe about them? So we can say that their exponents are divisible by 3. So if you see that the exponents of any variable is divisible by 3, then we can say that that variable is a perfect cube. Now let us remember, perfect cubes have cube roots. Now what are cube roots? So let us try to understand them. So earlier we have listed the first 5 perfect cube numbers: 1, 8, 27, 64, and 125, and they are the result of multiplication of a number 3 times to itself, such as this listed here. Now, these perfect cube numbers can be extracted with cube root. So what are the cube roots? For 1, the cube root is 1. For 8, the cube root is 2. 27, the cube root is 3. For 64, the cube root is 4. And for 125, cube root is 5. So basically, these cube roots, when multiplied 3 times to itself, they will be equal to the perfect cube numbers that we have listed earlier. Similarly, for the perfect cubes in terms of the variables, a cube, b raised to 6, c raised to 9, d raised to 12, e raised to 15, our examples earlier, which are the result of multiplication of a particular variable 3 times to itself, such as this listed here, we can also extract to them their cube roots. So for a cube, we have a, b raised to 6, that's b squared, c raised to 9, that's c cubed, d raised to 12, that's d raised to 4, and for e raised to 15, that's e raised to 5. So for our first example, we have a cubed plus 64. So for our first step, let us prepare first our parentheses and make one of the parentheses longer. Why? Because for the first parenthesis, this will be the location for our binomial factor, and for the second parenthesis, this will be the location for our trinomial factor. Okay, so first, let us get the binomial factor. So how to do that? First, we will get the cube root of a cube. So as we have learned, a cube, its cube root is a. Then, next, we will copy the sign that is found in the given, which is the plus sign. And then lastly, for the second term, get its cube root, and we will write it here. So for 64, the cube root is 4. Now the binomial factor is obtained. Now we will focus now for the trinomial factor. So first, we focus on the first term of the binomial factor, that is a, get its square. So that means that we will multiply a 2 times to itself. A times a, that's a square. Then next, we will consider the sign at the middle of the binomial factor. So the pattern is, if the sign in the middle is positive, we will have minus and plus sign here. This will be automatic. This is the pattern. Now, after that, we will get the square of the second term. So 4 times 4, that is 16. And we will write it as the last term of the trinomial factor. Now, after that, for the middle term, we will multiply the first term and the middle term of our binomial factor. So that means a times 4, which is equivalent to 4a. Now, our trinomial factor is complete. That means that we have now obtained the factored form of the given binomial a cubed plus 64. Now, for our second example, we have the binomial x raised to 6 minus 125. This is now under the difference of two cubes. So, what are the steps to follow? Let us study. Okay, equal sign, then the two parentheses. The other parenthesis is wider. First step is to get the cube root of the first term of the given, x raised to 6. Its cube root is x squared. The next, we copy the sign that is found in the given, so that's minus. Then get the cube root of 125, that is 5. So the binomial factor is now obtained. Next, to get the trinomial factor, the first thing to do is to square the first term of the binomial factor. So x squared times x squared, that is x raised to 4. And then look into the sign found at the binomial factor. So if it is minus, then the pattern will be 2 plus signs. Next, to get the middle term of the trinomial factor, just multiply the first and the second term. So x squared minus 5, that is 5x squared. And lastly, for the last term, we get the square of the last term of the binomial factor. So 5 times 5, that is 25. So there you go. That is now the factored form of the given binomial x raised to 6 minus 125. For our third example, we have 27c raised to 12 plus d raised to 6, another sum of two cubes. Get the cube root of the first term, 27c raised to 12, that is equivalent to 3 for 27, and for c raised to 12, that is c raised to 4. Then affix the sign, that is plus sign, then get the cube root, that is d squared. So this is now the binomial factor. Next, for the trinomial factor, square the first term, so that's 3 times 3, 9. C raised to 4 times c raised to 4, that's c raised to 8. Then affix the sign, so since this is plus sign, the pattern is minus, then plus. For the middle term, multiply the first term and the second term of the binomial factor, that is equal to 3c raised to 4d squared. And for the last term, square the last term of the binomial factor, d squared times d squared, that is d raised to 4. So now we have obtained once more the factored form of the given binomial. For the example, another difference of two cubes. Get the cube root of the first term. So 64, its cube root is 4. Cube root of c raised to 9, that is c raised to 3. Then copy the sign, minus. Cube root of d raised to 9, that's d raised to 3. Next, square the first term of the binomial factor. So 4 times 4, that's 16. C cube times c cube, that's c raised to 6. Then since this is minus sign, pattern is 2 plus signs. For the middle term, multiply these two. We have 4c cube d cube. And then for the last term of the trinomial factor, square d cube, that is d raised to 6. The factored form of the given binomial is now obtained. And for the last example, we have 8e cubed plus 64g cubed. Get the cube root of 8e cubed, that is 2e. Affix the sign, that is plus sign. Get the cube root of 64g cubed, that is 4g. Now for the trinomial factor, square the first term, 2e. That's 4e squared. Since this is plus sign, the pattern is minus, plus. Then multiply the first term and the second term of the binomial factor, that is equivalent to 8eg. And then square the last term of the binomial factor, 4g raised to 2, or that is equivalent to 16g squared. So this is now our final factored form for the last example, 80 cubed plus 64g cubed. So there you go. Congratulations. You have now learned how to factor the sum and difference of two cubes. So this is now the end of our video. Thank you for watching, and once again, I will see you in my next one. Peace.